Hello everyone, welcome back to our channel. Today we're diving into the world of calculus and exploring the derivative of the cosine function, cosine x, and cosine inverse x. Let's get started. To find the derivative of cosine x, we'll embark on a visual journey using a unit circle. Imagine a unit circle with a radius of 1 unit where the hypotenuse subtends an angle of x radians. The adjacent side, denoted as OB, corresponds to the value of cosine x. Now, let's increase the angle by a small value dx, leading to a new side, OD, representing cosine x plus dx. To isolate the change dB, we turn our attention to the arc length, which, for small angles, approximates to a straight line. This arc length, equal to dx, since arc length is equal to the radius times the angle subtended, is represented by the line CA. For a small change in the angle, the change in cosine x is equivalent to the sine component of the arc length given by the line MA, which is equal to the length of dB. To find the length of MA, we start with the base angle AOB. The angle MAO is also equal to x since they are alternate angles, and since angles CAM and MAO are complementary, being between the radius and tangent, angle CAM is equal to 90 minus x. Therefore, the required angle MCA is equal to x. Consequently, the sine x component of the arc CA constitutes the length of the change in the cosine x side. By further simplification and observing that as the angle increases, the cosine component decreases, hence the change in the function will be a negative change. Taking the ratio of the functional change to the angular change, we get the derivative of cosine x to be minus sine x. Moving on, let's explore the derivative of cosine inverse x. Cosine inverse x performs the inverse operation of the cosine function, taking the value of cosine and returning the corresponding angle. Now, to find the derivative of cosine inverse x, first, we change the angle notation from x to theta, as x generally represents the independent variable, and here the independent variable is the cosine component and not the angle. Therefore, we replace the angle with theta in all other terms accordingly. Assigning cosine theta as x, the change in cosine theta represents dx. Using the Pythagorean theorem, we express sine theta as the square root of 1 minus cosine squared theta, or the square root of 1 minus x squared. The dependent function, d theta, is defined as d cosine inverse x. To find the change in angle in terms of x, we notice that dx is the sine component of the arc CA, and as angle theta increases, the value of x decreases, therefore their relationship will be negative of each other. Hence, we rearrange this equation for d cosine inverse x. The final result, obtained by taking the ratio of the cosine inverse function with the change in x, yields the equation for the derivative of cosine inverse x. And there you have it, a visual proof for the derivative of cosine x and an exploration of the derivative of cosine inverse x. Understanding these concepts opens the door to a deeper comprehension of calculus and its applications. If you enjoyed this video, don't forget to like, share, and subscribe for more engaging content. Until next time, happy learning!